Welcome back. In this video, we are going to solve problem 13-8 that is taken from chapter number 13, Buckling of Columns, and book name is Mechanics of Material by R.C. Hibbler, 9th edition. So statement is a 2014 T6 aluminum alloy hollow circular tube has an outer diameter of 150 millimeter and inner diameter of 100 millimeter. If it is pinned at one end and fixed at other end, determine the largest axial load that can be applied to the tube without causing it to buckle. The tube is 6 millimeter long. So let's start with the solution. So what will be the first step? As we know that largest load before buckling from Euler's equation is P critical, and we can write this P critical is equal to pi square E times I divided by LE square, where LE is effective length, clear I is the moment of inertia, and E is modulus of elasticity. So what we are going to do is that we will first find this moment of inertia for this hollow section. So we know that moment of inertia for hollow section can be written as pi by 4 r outer power 4 minus r inner power 4. So we have been given that outer diameter is 0.150 meter. So outer radius will be equal to d naught divided by 2, which will be equal to 0.075 meter. Similarly, r inner will be equal to d inner divided by 2. So d inner is 0.1 divided by 2 is 0.05 meter. Now you have values, just plug it in this formula. So pi by 4 multiply by 0.075 power 4 minus inner is 0.05 power 4, and we will solve this by using calculator. So let's do it. That is 0.075 power 4 minus 0.05 power 4 is this one, multiply by 3.1417, which is the value of pi divided by 4, and that will be equal to 0.00019994, and unit will be meter power 4. And if you can write it like 19.94, then there will be 10 to the power minus 6 meter power 4. Now we have this I. We will also find the area. Why? Because this will be used in validation of answer. So area of circular cross section is pi if you have radius, so it will be r naught square minus r inner square. So just plug in the value. Pi multiplied by r naught is 0.075 square minus r inner is 0.05 square, and unit will be square meter. Now we will solve this. 0.075 square minus 0.05 square, and that is 0.003125 times pi, and we can also write it as 3.125 into 10 to the power minus 3 multiply by pi, and unit will be square meter. Now what will be the value of E? So you can see that E value and yield stress will be taken from the average mechanical property table. Average mechanical properties table that is available at the end of this book. So we will move and we will get both the values. So let me show you here at the end of book. You have to go the average mechanical property. You have to locate the material, just like this is 2014 T6 aluminum. So modulus of elasticity is 73.1 gigapascal, and yield stress is 414 megapascal. So just write it. 700 E is 773.1 gigapascal, and that yield stress was 414 megapascal. Now what about effective length? So effective length is equal to K multiplied by L. And what is K? So we have to go to the again toward the book, and in question we have been given that one end of the column is pin while other end is fixed. So we will check it. Here you can see that in case number D, you can see one end is pin and other end is fixed. So K value is 0.7. So I will choose here, I will pick the K value 0.7 multiplied by length is 6 meter. So it will be 0.7 multiplied by 6. Now you have all the values, just plug it in this formula. So what we will do is that I will write the formula. P critical is equal to pi square E times I divided by LE square. So pi square E is how much? 73.1 into 10 raised to power 9 Pascal multiplied by I, which we have calculated was this one, 19.94 into 10 raised to power minus 6 divided by LE square, which is 0.7 multiplied by 6 whole square. Okay, we will solve this and we will write the value of P critical. So let's solve it. 3.1417 square multiplied by 73.1 into 10 power 9 multiplied by 19.94 into 10 power minus 6 will give you this, and when you divide this answer by 0.7, divide by 0.7 multiplied by 6 whole square. So you can see you have this 814,365.712 newtons. Okay. Now when you in term of kilonewtons, you can write it as 814.36 kilonewton. So this is the maximum critical load or maximum axial load that can be applied to this hollow circular pipe that will not cause any buckling. Also, we will confirm it by using by finding critical stress, and as per Euler's formula is only valid when your critical stress is less than yield stress. So what we are going to do is that we will find critical stress. So critical stress is equal to critical load divided by the area. So critical load is 814.36 into 10 raised to power 3 divided by area is 3.125 into 10 raised to power minus 3 multiplied by pi, and unit will be here Newton and here it will be square meter. Now we'll solve this. So 814.36 multiplied by 1000 divided by area, which is 3.125 multiplied by 10 raised to power minus 3 multiplied by 3.1417. That is equal to 8294108.85. And this critical stress, when this decimal point will go 1 2 3 4 5 6, so it is 82.9 megapascal. So I can write it as 82.9 megapascal, which is approximately, this critical stress is approximately equal to 83 megapascal. Now you can see you have yield stress, that is 414 taken from mechanical property for this material, and we can see that critical stress, which is 83 megapascal, and that is less than yield stress, which is 414 megapascal. So it means our design is okay, and this critical load is the safest load, largest axial load that can be applied to this hollow circular tube without causing any buckling. So this was all about this problem 13-8. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching.